But I'll just explain, I guess, kind of what we're looking at here in this particular trial. So this one is focusing on nitrogen, and we're basically first generating a rate response curve where everything is sidebanded, and we've either got 0, 0.5, 1, or 1.5 times our recommended fertilizer rate based on soil test recommendations. For that, we were targeting a total soil plus fertilizer of 125 pounds per acre, I think is what it works out to. And you might feel that that's a little bit light, and I do too, but we did that again for a very specific reason. We wanted to be able to have the rates low enough that we would be able to get some separation between the different application methods and, of course, the different formulations that we're looking at here. So on top of just that basic rate response, we've got a few different timings. Spring broadcast, we would have liked to have done fall, but the project was only initiated in the spring, so we just focused on that spring broadcast application. Sideband, which I guess we would consider essentially our gold standard, so that's all one pass seeding fertilization. This is a Seedmaster drill, so our fertilizer is placed, I want to say, 3/4 of an inch below the seed and a little bit to the side is our configuration there with the sideband. And then we have a final set of treatments where we did a split application where 50% of that nitrogen went down as side-banded urea, untreated urea, and then the remaining top-up was either liquid UAN in a surface dribble band or broadcast super urea or agrotane or untreated urea. And that top dress application happened 6 to 8 weeks after seeding, essentially. So we wanted to get it on kind of later in the vegetative growth stages, but well enough in advance of the reproductive stages that we could still be confident that the crop's got time well, I guess first to get that nitrogen moved into the soil, into the rooting zone, and then give that crop enough time to actually take it up and make use of it before it went into peak biomass uptake. This is our first year running the trials. You can see we have 31 pounds residual was what we had in the fall, so that's what we were kind of working on as a baseline. I resampled this site in the spring, and that number actually, whether this was actually a change or just sampling variability, but we came up with a little bit lower number in the spring, about 20 pounds residual. And then everything else, other than our few rates of side-banded, so where you see the 0.5x or the 1.5x or the no fertilizer, everything else has gotten the same rate. All that differs is either the form of fertilizer applied or the method in which it was applied. This is a trial that, really could get huge. There are so many options out there when it comes to managing fertilizer and different timings, different placement methods, all the different forms that are available, the different approaches to split nitrogen. Here we just went with 50-50, where half of it went up front and the other half went in the season, but we've done a lot of work historically where we looked at different proportions of that nitrogen. Stu is involved in some of this work as well, but basically looking at different proportions of starter nitrogen, how much did we need to apply right up front to make sure that we weren't losing yield, and then on top of that, how late could we defer our post-emergent applications and still correct any nitrogen deficiencies without, again, subjecting ourselves to unnecessary risk of yield loss. So we do have quite a history of that type of work. Actually, I did my master's on split applications of nitrogen as well, where we were then using the green seeker to come up with appropriate top dress N applications and applying those on a variable rate or in the small plots fixed rates, but still using the sensors to actually measure differences in crop response and try to fine-tune things that way. So you'll see by the sign back there really refers to 4R nutrient management, and just a little bit of background on what we're talking about when you hear this term 4R nutrient management. It means getting the right form, so the right product, at the right rate. We know how difficult it can be to come up with an appropriate rate, but that's something that we need to do the best that we can. The right time, so ideally you always want to put that fertilizer down as close to crop uptake as feasible. Of course, logistics certainly play a role there, and again, it comes down to giving farmers options. And what else? Right place, so the right method of placement. And basically, we want to place that product somewhere where it is both accessible to the crop and also not susceptible to environmental losses, whether those might be leaching, denitrification, loss with soil erosion, lots of different ways that, depending on the nutrient you're dealing with, things might be able to be lost. So right place, right time, right form, right rate. Those are the things that, for any nutrient, no matter what you're working with, those are really the 4 things that I guess you should be thinking about and be willing to tweak to make the best use of that fertilizer. And I don't know if Regas touched on this or not, but I did mention it this morning, just that it is good news from both an economic, I guess, farmer perspective and also environmental, that really our goals are aligned. It's in a farmer's best interest to make the best use of that fertilizer, get it into the crop as opposed to somewhere else where we don't need it and it's likely to do harm. And it's also, from an environmental perspective, that's also in our best interest. I mean, we don't want it to end up in the water or gassing off, affecting maybe greenhouse gases, things like that. So really, I think there's a lot of common ground between a farmer's interest and just the broader societal environmental interest as well. And that's really what 4R nutrient management is about. It's about getting you guys the best value for that fertilizer and also minimizing potential for harm and I guess a method of even verifying that to the public that things are being managed in a responsible and efficient manner. I don't have much to say about the trials specifically. It's our first year running them, but we will be able to pull together a nice tidy report for you. Like I say, we do have, I think every single one of the Agri-ARM locations is working on this to at least some capacity, and we'll be pulling reports together for both the province and for Fertilizer Canada, and all that's going to be made publicly available through our own sites and through the Fertilizer Canada website. And we'll see. We're hoping to continue, a little bit of work, at least along these themes, going into the next years as well. And realistically, I mean, 4R nutrient management work has been the bulk of our program for as long as I've been at that job. I mean, just being on the tour today, you can see how all of these different things really come into play with a lot of the work that we're doing. Maybe we're not manipulating them all in the same individual trials, but it's really, whether it's rate determination or evaluating different placements, things like that, different forms, it's a big part of a lot of the work that we do. And nutrient fertilizer is I think this is probably still true for most crops, the single greatest expense for crop production. So, and also nitrogen specifically, if you want to think about energy, more energy, or the vast majority of the energy used to produce a crop is related to that nitrogen fertilizer that we're using to grow that crop, because it is a very energy intensive process just to get the nitrogen out of the air into the nice little fertilizer granules or liquid formulations that we know and love.